Okay, in the last lecture we studied a general introduction to functions, and we have known that functions are known by how it operates on its inputs, and it is defined by its domain, and we have known the domain and the range of the function and how to find the domain of some functions. Okay, also we have learned how to know the symmetry of the function. What is symmetry of the function? It is how to know if the function is even or odd. Okay, these are some skills that we have studied in the last lecture. Okay, in this lecture, this is part of the last lecture, but I couldn't manage to give it in the last week, so we'll give it today. This is called transformations of functions. What are transformations of functions? It means that if I have a function, a known function that I know very well, something like f of x equals x squared, and I make a little change. Such as if I take every x and put instead of it x plus 3. Okay, what would be the modification in the graph of the function?
Up to 3 of y positive.
Y? No, this is not correct. This is called a shift. Okay. Now this operation is affecting x. So this is a horizontal operation. Okay, this is a horizontal operation. Okay, why? Because the operation here is made on x, not on y, or not on the whole function. Okay, so this is x. We are making the operation on x. We are saying that we will substitute for every x, we'll put instead of it x plus 3. What would be the effect in this case? If we are taking x plus 3, x plus or minus, it is called a shift. So this operation is called a horizontal shift. This is a horizontal shift. Now this horizontal shift, is it to the right or to the left? Is it to the right or to the left? No, it will be to the left. Why? Now, look. Whenever I have an operation on x, the transformation that is made will be in the opposite of what I predict. What do you mean by that? This is plus 3. I may predict that it would be to the right plus 3. No, it will be to the left plus 3. To the left 3, or that will be horizontal shift. We will say it would be negative 3. So this is horizontal shift. Negative 3 means 3 steps to the left. 3 steps to the left. Okay, so what will be the new graph of the function? That will be like this. So why would it be like this? Now this new function, I want to graph this function, to write this function, to write the expression of this function. What would it be? It would be x plus 3 all squared. Okay, this is the new function. It is called f of x plus 3. We may recall it a new name. It will be, for example, g of x. Okay, so this new function is like this. Why would it be shifted to the left, not to the right? Now look, this point is very special. This is called the vertex of the graph. This happens when whatever it is squared is equal to 0. This happens whenever what is squared is equal to 0. So that happened when x was equal to 0. That point happened when x was equal to 0. Now in this case, when would that point happen? When what is squared is equal to 0. Now when what is squared is equal to 0, when I say x plus 3 is equal to 0, that would mean that x is equal to negative 3. So in this new case, it will be at that point will be at negative 3. Okay? So that's why it is shifted to the left instead of, and a general rule. You may, in a horizontal operation, if you predict something, the transformation will be in the opposite direction. Okay, so that was plus 3, so the horizontal shift will be negative 3 or to the left. Okay, and so on. If I say if I take every x to be x minus 2, what would be the graph of this function? Or what? That is a horizontal shift. Plus 2. What is meant by plus 2? It means 2 steps to the right or to the left? Now this guy, yes, in this case it will be to the right. In this case it will be to the right. Yes, because it is in the opposite of that number. Okay? So, in transformations of functions, it is better, always better to write this arrow like this, and above it I describe the operation mathematically. I say what happened mathematically, and beneath it or under it or below it I write the interpretation of the transformation that happened. Okay, so I know that x plus or minus sum a, this is called horizontal shift, negative or plus a. Okay, so this is the first transformation, and that is called horizontal shift. This is first transformation, it's called horizontal shift. Okay, now let's see another transformation. If I take this function, which is x squared 2, f of x is equal to x squared, and what I make this time, mathematically, I will take the whole function and I say plus 3. I take the whole function and I say plus 3. This square, I symbolize it to the whole function. So this means this function, whatever it was, I just put it in a box and I symbolize it like this. I put that box to symbolize the whole function. This is the whole function, whatever it was. Okay? So this is the whole function. This is what would I mean? What would I do mathematically? So what would be the result in this case?
3 steps to the next.
No. I'm not asking about the interpretation of the transformation. I'm just saying, if I take the whole function and I say plus 3, what would be the new expression? The new expression of the function. What would it be? The new expression of the function would be x plus 3 all squared. What would it be? X, yes, it will be x squared, which is the whole function, plus 3. So this is the new expression. This is the new expression of the function. Okay? Now this, I want to graph this. How would I graph this? I know that this is interpreted as this is called, whenever I make an operation on that box, or the whole function, or the y, now this will be a vertical operation. This is operated on the y, or that box represents the y. Okay, so that is a vertical operation, and it is plus, so it means that it is a shift. Any plus or minus, it is called a shift. So it is a vertical shift. Now in this case, in the vertical case, whenever you predict, it's just the exactly or the right or the correct direction. So if I say here plus 3, so that will be horizontal shift plus 3 too. Okay, so that will be also plus 3. Or I mean that's 3 steps upwards. Now we are talking vertical. So vertical, it will be either upwards or downwards. Okay, so in this case, that will be, the function will be something like this. It starts from 3 like this, and so on. If I have a function like this, x squared, and I make that will be minus 2, so that will be, yes, this is vertical shift minus 2. Any vertical operation, it operates just like the same expression. Okay, so that will be 2 steps downwards. Yes, 2 steps downwards, 2 steps downwards. So in this case, that will be something like this. So that will be like this, minus 2. Okay, so this is the second operation. This is the second transformation, which is called vertical shift. This is called vertical shift. Okay, now we will start by another transformation, which is called scaling. That was shifting horizontal and vertical. Shifting horizontal and vertical. Okay, now we will say scaling. Scaling, we also have 2 cases, which is horizontal scaling and vertical scaling. What is scaling? Scaling is either a compression or expansion. Okay? Vertically or horizontal. Okay? So this is what is called scaling. This is what's called scaling. Now scaling, let's check horizontal scaling. Now horizontal scaling, if I say, for example, if I have f of x is equal to x squared, so this is my function, like this. And now, how would this operation happen, or how would this transformation happen? If you remove, now this is a horizontal operation, so I am predicting that it will be operated on x, not the whole function. It is a horizontal operation, so it is on x, not on the function. I take every x to be, for example, 2x. If I remove every x, or I substitute for every x to be 2x. So what is the new expression for the function? It would be 2x all squared. 2x all squared. Now what is this operation? Multiplying by 2, I may predict that multiplying by 2 that it gets greater or it expands. No, it is a horizontal operation, so it will be compressed in the opposite. So the same rule. Whenever you have a horizontal operation or horizontal transformation, it will be in the opposite of what you predict. Multiplying by 2, you may predict that multiplying by 2 gives double the size. No. It is a horizontal operation, so it will be half the size. It will be half the size. So this is called horizontal compression. This is called horizontal compression. Okay? Called horizontal compression. So what will be the new graph of the function? It will be something like this. It will be something like this. It is compressed like this. Okay? The compression is about the y-axis, so you are compressing about. Okay? Now if I have f of x is equal to x squared 2, and this is the function, but in this case I make it x over 3. So that the new expression will be x over 3 all squared. What is the new graph? It will be, this will be horizontal expansion now. In this case it's called expansion. Just the opposite of multiplying by 1 over 3, you may predict that 1 over 3 or dividing by 3 will shorten or may compress. No, it will make the opposite, as it is a horizontal operation, so it will be horizontal expansion. Horizontal expansion. So what will be the new graph? The new graph would be something like this. I just expanded it horizontally. Okay? This is for horizontal scaling. Compression or expansion, either two is called the scale. Okay? This is called the scaling in general. Now, also we have vertical scaling. Vertical scaling. What is vertical scaling? Vertical scaling, now this is a vertical transformation, so it will be operated on x or on the whole function? On the whole function, because it is vertical. It is vertical, so it will be in the whole function. So I predict that it will be that box, because it is vertical. So if I have f of x is equal to x squared, like this. Okay, now if I take the whole function and, for example, multiply it by 4, the whole function is multiplied by 4. Now this is a vertical operation, this is vertical. Would it be compression or expansion in this case? Now yes, this is a vertical, so it will be as I just predict, so that would be a vertical expansion. That will be a vertical expansion. Okay? Now what would be the new graph? That would be x squared, 4x squared. So that new graph will be something like this. I just expanded it like this. Now, some of you may notice that this graph is much like this one. Yes, and for this special case, yes, it is exactly the same graph. Why did that happen? Now look, this 4x squared, I may see it as a 4 multiplied by the x squared. Or I may say it in another way. Do you see it in another way? Yes, it is 2x all squared. It is just 2x all squared. So this same function, I may say it as a modification of x squared either by a vertical expansion or by a horizontal compression. But is it always in a case of a horizontal expansion or a horizontal compression, would I have a vertical expansion? No. This is just a special case in this just case. In this case, in just case. Okay? It is not general. It is not general. For example, we have some function, we will know it in this lecture, which is known as sine function. If you make a horizontal compression, it will just be like this, or like this. But I'm making now horizontal compression. Did that affect the vertical height, for example, of the function? No. So some of you may say that whenever I have a horizontal expansion, I'll give it. No, this is not correct. These are two separate operations. But in just this special case, it just happened. Okay, and we have just interpreted. Why did that happen? We have known that now. Okay, when I have f of x is equal to x squared also, but I make now that would be 1 over 3. 1 over 3. So that would be called vertical. Yes, vertical compression. This is vertical compression. So that would be something like this. Okay, now we have studied horizontal shift, vertical shift, horizontal scaling and vertical scaling. Now we'll study reflections. Reflections are connected to negative signs. Okay? Now we have also a horizontal reflection. We have horizontal reflection and we have a vertical reflection. What is a horizontal reflection? Horizontal reflection when we take every x and make it substituted with a negative x. If I have x and substituted with a negative x, what would happen in this case? What would happen, for example, if I have this function, if I have some graph like this, for example, this graph, and I make every x to be negative x. That is called horizontal reflection. What is a horizontal reflection? It is just, yes, horizontal flip. If you know how to use the image filtering and so on, image editing, there is also an option. There is always an option which is called horizontal flip. Horizontal flip, which is just exactly what is called horizontal reflection. It is about the y-axis. It is about the y-axis. Okay. So the new graph would be like, it would be something like this. It would be just like a mirror. The y-axis is just like a mirror in this case. So that would be, the graph would be something like this. Okay, so this is called horizontal reflection. This is called horizontal reflection. What is vertical reflection? Vertical reflection, if I remove, now this is a vertical operation, so it will be on the whole function. It will be on the whole function. So it will be, yes, if I multiply the whole function by a negative sign. Multiply the whole function by a negative sign. So that would be called a vertical reflection. What is a vertical reflection? If I have a function like this, what is the vertical reflection of this function? It will be something, can you predict? What is the vertical reflection? It is about, what would be about the, which axis I am reflecting about?
X.
Yes, the x-axis in this case. So it would be something like this. So this is the new function minus the function, and this is the function itself. This is the function itself. Okay? Okay. So these are two reflections, horizontal reflection and vertical reflection. Now also we have absolute reflections. What are absolute reflections? We have absolute reflection. If I have some function like this, for example, if I have this function like this, for example, this function, this is the function f of x, and I want to graph what will happen here. I will just take it just inside an absolute. I will put the whole function inside an absolute. I will put the whole function inside an absolute. What would happen to this function? So if, for example, I have some f of x, the whole function will be absolute f of x. That is the function after the transformation. Now what would be the new function? What does the absolute function do to its input? Do you remember? Yes, it turns the negative to positive. What about the positive? Does it change it? No. It keeps the positive as it is. So in this case, anything that is positive, it will just keep as it is. But the negative, yes, we are starting now negative, so it will be a positive. So it will be like this, and this. Okay, so this is the red graph is just absolute f of x, and the blue graph is f of x itself. The blue graph is f of x. Okay, so that is absolute reflection. Also we have x absolute. What is x absolute? It is, instead of the whole function inside the absolute, I will just make substitute for every x to be absolute x. Substitute for every x to be absolute x. So this is called x absolute. It's called x absolute. Okay. What would happen to a function in this case? Yes, this is a tricky one. This is a tricky one that is a little bit different from all the previous transformations. If I have a function, for example, like this. If I have a function like this, I love to call this transformation called evening of the function. Evening of the function. The evening is not the midnight or that is evening. It is making the function even. Making the function even. What is meant by making the function even? So what transformation would be in this case? Just concentrate with me. It will be in the positive x side. It will be as it is. It will be the same. But I will make evening for it. So I will just remove that part. The negative side, I will remove it. And I complete the graph just to be a reflection of it. So the whole graph will now be like this. So that's why it is called evening of the function. It makes it even. Do you remember what is an even function? What is an even function? It seems you are not studying. You are not studying. What is even function? Even function that is symmetric about the y-axis. Now look at this output. It is obviously symmetric about the y-axis. Okay? So that is how we make an x absolute. We remove the negative side. All together. Then we reflect the positive side to the other side, to the negative side. Okay, we remove the negative side, so we have two steps. Remove the negative side, plus reflect the positive side to the negative side. Okay, so that is how we make these. So these are the transformations that we have to study. Now let's check some examples. Some exercises. We need to have two skills. I give you a starting function, for example, x squared or x cubed. I tell you starting from x cubed. I want you to make transformations until you get x minus 1 all cubed plus 1. So I want to make transformations, sequence of transformations, sequence of my node. I've studied 7 transformations. Shift horizontal and vertical, this is 2. Scaling horizontal and vertical, this is another 2. So we have 4. And yes, we have studied 8 transformations. And the reflections are also 4. Horizontal reflection, vertical reflection, and the absolute reflections. Okay? One horizontal and one vertical also for the absolute reflections. Okay? Now, I want to start from x cubed. And I want the final destination would be x minus 1 all cubed plus 1. How would I get to this expression? I want to make it in steps. Each step is just one transformation that I've studied. In each step, I just use one transformation. Okay? In one step, I just use one transformation.
Horizontal.
Yes. I would make here first, for example, I would say that if I remove every x to be x minus 1. So that will make me closer to the expression that I want. It would be x minus 1 all cubed. What is the interpretation of this? What it is called?
Horizontal shift.
Yes, it is called horizontal shift. Negative 1 or plus 1? Plus 1. What is meant by plus 1? It is to the right, plus 1. The positive is right and negative is left. Okay? So if I know, do I know the graph of x cubed or not?
Yeah.
Yes, I know the graph of x cubed, which is like this. Now what is the graph of x minus 1 all cubed? It would be shifted 1 to the right. So it would be like this. It would be like this at 1. Now I just want to make a transformation that gives me this. I just think this is just one transformation, which would be, what do you think? I would make it to be x minus 1 all cubed plus 1. How would I get this? I will take the whole function and make it plus 1. The whole function and make it plus 1. Just it will give me this desired output. This is the required output. So this operation will just give me what I need. So I take the whole function. This is the function in the box. Function in the box. I make it plus 1 and gives me this. Okay. What is this called? Vertical. It is vertical. Vertical. Shift or scaling or reflection or what?
Shift.
Yes, a vertical shift plus or minus is a shift. Plus or minus is a shift. Multiplication by a number is a scaling, horizontal or stretch, or compression or expansion. Okay? Putting an absolute or a negative is a reflection. Multiplying by a negative is a reflection. Either it is multiplying the x or multiplying the y or the whole function. Putting an absolute, it is an absolute reflection. Okay? So these are the whole transformation that we have. So this is called vertical shift. Plus 1 or negative 1?
Plus 1.
Yes, this is plus 1. So the graph of the new function would be like, I will just take it up, plus 1, so it would be something like this. This is 1 and 1. Okay, this is the new function like this. Okay, another example. What if I need to graph this one, negative x and negative 1 all cubed to plus 1?
Can I make a condition?
I've managed to make this. Now I want to, from this one, I want to, how could I get this one or not? Can you see a transformation from this one to this one? Yeah?
By reflection.
Yes, reflection. It is obvious here. What happened from this case to this? I just remove every x to be a negative x result. So this will be a horizontal reflection. Horizontal reflection. So what is a horizontal reflection? What would it be the graph? Horizontal reflection. The reflection, it is defined by its the movement, by the movement. So I'm moving here, I'm moving horizontally. I'm moving horizontally. This is I'm moving vertically. This is vertical reflection. This is horizontal reflection. Okay? Now, horizontal reflection, so that will be, yes, it will be reflected to the other side. It will be something like this. It will be something like this. Okay?
مش المفروض يا دكتور على الزيرو
لا احنا خدنا دي اللي عملنا لها فرق. ايوه بنكمل عليها لان هي دي تكمله على دي. اوكي طيب if I want to start now, I want to graph. Yes, he is telling me here start from, or I start with the power function, the known power function. He's asking me to graph, find the graph of root 2x plus 4. Root 2x plus 4. I will start with root x. I know the graph of root x. Do you remember the graph of root x? Yes, it is like this. Now it is obvious here that I have two operations. A scaling, which is obvious from multiplying by 2 for the x, and there is also a shift for the plus 4. Okay? Either two, they are horizontal or vertical. Are they operating on the x or operating on the whole function? No, on the x. They are operating in the x inside the root. If I have it for the whole function, it would be something like this, or it would be something like this. So this is if it was for the whole function. No, this is for the x only. This is for the x only. Now, I want the final destination for me to be root 2x plus 4. Whenever I have, now look at this rule. Whenever I have something beside or a coefficient of x not 1, if I have a coefficient of x that is not 1, I just make the graph of what is simpler, or what is simpler, which is with 1 instead of 2. So I will just move backwards like this. I will start from here and I will just make it like this. Why? Because I know I can go from this to this by a very simple step, which would be x, to move every x to be 2x. Okay? So whenever I have an x that has a coefficient that is not 1, just like this one, if I have an x that is not that has a coefficient that is not 1, I just make a simpler problem, which is make it without the coefficient. Make it 1. You make it 1. And solve this first. If you solve this, I will just easily make the new one just by taking every x to be 2x. Okay? Okay. Now, how can I get from this one to this one? From the root x to the root x plus 4. What is this called? I take every x. Now, whenever I have an arrow, above it I express the mathematical operation, and below it I express it the meaning of the operation. Okay? Whenever I make that arrow, I put 4 above it I just put x plus 4. That I took every x and substituted with x plus 4. Okay? And below it? Yes, that would be yes, horizontal shift. Plus 4 or negative 4? This is negative 4. Negative 4. Okay. So that new graph would be something like this. Negative 4 to be like this. Now I need to make this operation, which is easy to expect from this one to this one. What is this operation called? Horizontal scaling. But I need to determine which is a scaling. A scaling are either a compression or an expansion. What would yes, that would be a compression. Yes, that would be a compression. So it will be a compressed version of this one. Compressed about the y-axis. Compressed about the y-axis. Now, how would I make that compression? It will be something like this. Now, a very important note here, that this number, any number that is not on the axis itself, it will just be compressed by the same factor. What would I mean by this? That negative 4, now you are making a compression by a factor of 2. Compression by a factor of 2. So that compression means it lessens or it becomes smaller. Okay? So that negative 4, you will divide it by 2. So that will be negative 4 over 2, which is negative 2. So the new position of this point, it will be just negative 2. Okay? So whenever I have any point that is not on the axis itself, I just check if you are making a compression, so that will be divided by the factor. If you are making an expansion, that will be multiplied by the factor. Okay? So this is one way to solve this problem. Is there another way? Yes, there is another way. There is another way. You may switch the operations, but the numbers will be different. You may start by the scaling, then you make the shift. You may start by the scaling, then you make the shift. How? I just see this function, I see it like this. Root 2x plus 4, I can take 2 as a common factor like this. I just can take 2 common factor like this. So how would I start? I would start with x, then I take every x to be 2x. Take every x to be 2x. That is horizontal compression factor 2. So that will be like this, and that will be root 2x. Okay? To be compressed. To just be compressed like this. Now, what operation would I do to get this new function 2x plus 4, or which I can similarly express it as 2x plus 2. What operation would transform this to this one? Take every x, take the whole function. What would I do in this case?
vertical shift. vertical shift.
ايوه انا عايز اللي هي الحاجه اللي فوق، يعني تقول لي اشيل كل اكس احط حاجه، ولا الفانكشن اعمل فيها ايه؟ الفانكشن البوكس بتاع الفانكشن ايه؟ vertical compression. طب if I say I need to make it as a horizontal operation, what is meant by horizontal operation? I remove every x to be, so I want to substitute for this x to be x plus 4 or 2? 2, yes, exactly. This will be x plus 2. This is what exactly happened here. I just removed every x, or substituted for every x to be a bracket which is x plus 2. Now what is this operation is called? Horizontal shift
Plus 2.
minus 2.
negative minus 2. Horizontal shift minus 2. Okay? Okay. Now I just need you to notice that switching or interchanging the operations did change the numbers. Now this was a horizontal shift negative 4, but this is a horizontal shift negative 2, so the numbers are changed. Okay, this is horizontal compression. Okay, this is equivalent, but this one, if you change the order of the operations, the result may change. Okay, changing. So it is not just simply I could make a scaling then a shift. Then you say that I want to make it a shift first than a scaling. If you make it with the same numbers, it will give a different result. Okay.
First is right, yes. First is right.
Both are right. This is right and both are right. They both give me the same horizontal shift negative 2. It will be just like this. This one is just like this one, or it will be. They are both the same. They are both correct. Okay? And both give me the same expression, the same final expression. If I have this function 1 over 1 plus x squared, I want to arrive to this. This is a bit tricky. This function is what if I take here a common factor 4 from to be x1? I just want to make the same expression like this. Okay? Now could I say that this one to this, I say that it's a vertical shift plus 3. Is it correct or not?
Plus 4.
Vertical shift plus 3 from this to this. A vertical shift plus 3. Is it correct?
Plus
No.
Plus 4.
Neither plus 4. It is all incorrect. Why? If I make a vertical shift plus 3, what would be the expression of the new function? Vertical shift plus 3. What is the new function? It will be 1 over 1 plus x squared, but plus 3. This is the whole function plus 3. That is the vertical shift. Okay, so this is not what I need. I need to get this expression. This expression, the 4 is in the denominator. So it is obvious that we will make a horizontal transformation, not a vertical one. Okay? But to express or to affect the x. Now, if I take the 4 as a common factor from the denominator, what would remain? It would be 1 plus x squared over 4. X squared over 4. Okay? So, I can rewrite this as 1 plus x over 2 all squared. Now, can you get it? How can I get from this one to this one? I think it's obvious now. I would start with 1 x squared. I remove every x to be x over 2. Yes. So that would be 1 over 1 x over 2 all squared. This is called horizontal. شفت ايه؟
horizontal reflection.
تقولوا اي حاجه؟ هو reflection ده نيجاتيف. فين النيجاتيف هنا؟ ايه؟ horizontal scaling ده هيبقى compression ولا expansion؟ x over 2 x over 2 يبقى expansion العكس. ده opposite. يبقى دي هتبقى ده horizontal would be horizontal expansion ولا compression? Expansion. Horizontal expansion. Okay, now I've got this. Now I want to make it to get this one. What happened in this step? What happened in this step? From this function to this one.
All the function
Yes, all the function, the box, the whole box.
over 4.
Over 4, all multiplied by 1 over 4. Yes. This is called, it is a vertical operation or horizontal operation first? This is a horizontal operation or vertical operation? Multiplying the whole function by some number. It is a vertical. It is a vertical. Whenever I have this box, it is a vertical operation. Whenever I have this box, it is a vertical operation. Okay? Now, this factor, would it lessen or would it make it greater or bigger? Yeah, so to make it less. So that's what's called compression. Because we have learned that a vertical operation operates just inside in the same type that we have predicted. Okay? So these are the two expressions that gives me that one, which is at least this one. Okay? Now, if I have this function, x minus 1 whole squared plus 3 in the absolute. First, I need to graph what is inside. What is inside? It is just obvious. I make horizontal shift, then a vertical shift. Horizontal shift and vertical shift. So that would be something like this. X minus 1 all squared plus 3. That would be something like 1. Horizontal shift positive 1 and a vertical shift, so it will be something like this. No, I just want to make it a negative sign. A negative. I want to make it negative. So the graph would be like this. It would be 1, negative 3. It would be like this. Now I want to take the absolute of the function. So this is called absolute reflection. What would be the new result? What would be the result in this case? I just if I take the whole function and put it inside absolute, what would be the result? I just take the negative part, the negative y-axis, and take it up. So it would be something like this. It would be like this. If I needed to graph absolute x minus 1 whole squared minus 3. Now remember, this is x minus 1 whole squared minus 3. I want to graph this one. What is the operation from this to this?
Vertical, horizontal.
No. Let's concentrate. X minus 1 whole squared minus 3, and this is absolute x minus 1 whole squared minus 3. What happened in the expression? This is a horizontal operation or vertical operation. What happened? The change happened to the x or to the whole function?
To the x.
To the x. So this is so I removed every x to be
Absolute x.
to be absolute x. Just exactly. I just substitute every x to be absolute x. Now this is called x absolute. How would I make this? I'll take this one and take. I will. Do you remember? It's called evening of the function. I will just take the positive side as it is, but I remove the negative side and I make a reflection like this. So this is the graph of this function. Okay? If I need to graph root 4 minus x. Now remember, I now have a coefficient of x that is not 1. I will just start with root x. And I need to eventually be to x for root 4 minus x. Root 4 minus x. I just have told you, whenever I find a coefficient of x that is not negative 1, that is not positive 1, I just remove that coefficient. I just make a simpler problem to be like this. 4, I will just make it like this. Whenever it was negative, I just remove the coefficient of x to be positive 1. And I solve this first. And if I solve it, it is easy to go from this to this. That would be, I change every x to be minus x. Yes, this is called horizontal reflection. So this is my problem. Now how would I get from this one to this one? From root x to root 4 plus x. How would I get to this one? It is obvious. I remove every x to be x plus 4. Yes. So this is called horizontal shift minus 4. Yes, exactly. So that would be horizontal shift minus 4. It would be like this. Then horizontal reflection. So it would be like this. Okay, so this is the graph of this function. And also in this case, you may start by the opposite case. So one may start saying, I will just make it minus x. So to be, he will graph the graph of root negative x. Also the graph indeed is called horizontal reflection. So this is like this, and this one would be like this. Now I just want to be 4 minus x. What do you think here will be the operation? No, I want to remove every x to be
X minus
x minus 4 or plus 4?
Plus 4.
X plus 4. Let's check this. If I remove every x here to be x plus 4, if I remove every x to be x plus 4, what would happen? Minus, I will remove this x to be x plus 4, x plus 4. Is it correct? Minus x minus, this is that what I need? No. So this operation is wrong. Was it the correct one?
Minus x.
Minus 4. Let's check it. Let's check it. Minus x, I will just remove the x to be a bracket which is x minus 4. So that will be root minus x plus 4. Oh yes, that would be correct. That would be correct. So this is the correct operation. And if you need to know how to make this operation, you just take the coefficient of x as a common factor. If you want to know what operation would I do in this step, just take the coefficient as a common factor. So for this case, I will just take 4 minus x. I will take the negative as a common. Don't take it outside the root. I'm just taking it inside the root. So that would be x minus 4 like this. Now in this case, I just know what would substitute the x. In this case, I just know what would substitute the x. Okay, this is enough for the transformations of functions. Now we start for the new lecture. That was a part of the last lecture. Now we'll start with some functions that you must have been studied before. You must have studied before. This is sine, the trigonometric functions. Trigonometric functions. And the exponential function and the logarithmic function. Trigonometric functions are just that are coming from an angle theta, for example, or x, and I have here sine x to be ABC. Do you know what is sine x in this case? Yes, this is called B over C. B over C. And cosine x would be
A over C.
A over C. And tan x would be
B over A.
B over A. Yes, correct. These are called trigonometric functions. These are called trigonometric functions. So we will just make the graph of each function of these. Another way to look for the function, we just make it as a point moving. What are the sine or cosine? Another definition. Some of books name the trigonometric functions to be circular functions. Instead of trigonometric functions, they call it circular functions. Why? Because they are the coordinates of a point moving on the unit circle. If I have a unit circle like this, do you know what is the equation of the unit circle? X squared. Do you know this equation or not? X squared plus y squared equals to 1. Do you know this? Okay, this is the equation of the circle. A circle, for example, is x squared plus y squared equal to r squared. This is an equation of a circle with a radius r. Radius r, and origin 0 is the center. Origin is the center. Okay? Now, for this case, a point will be cosine, a point like this is theta, that will be cosine theta and sine theta. A point moving in that circle would be cosine theta and sine theta. That's why for this point is called 1 and 0. This point is called 0 and 1. This point is called negative 1 and 0, and this point is called 0 and negative 1. Okay? So this is the cosine 1. This one is the cosine of the angle. Which angle is this? This is called the angle 0. I start the angle from the positive x-axis. My reference of any angle is the positive x-axis. Okay? and this positive x-axis, and so this is called cosine 0. Now remember, I don't have a calculator in the exam. There are no calculators allowed in the exam. So you need to know the cosine and sine of the basic angles. What are the basic angles? Are these 4 angles. These 4 angles, I need to know the cosine and sine. And it is easy. It is just from the circle. If you see this circle, you will just know how to find these. So this is cosine 0 and this is sine 0. Sine 0. So I need to graph, if I make a graph for the sine and cosine, sine, cosine, sine 0 is equal to 0 and cosine 0 is equal to 1. Now for this angle, this is the cosine, yes, the cosine, I will not say it is 90, it will be pi over 2. We will call it in the radian. You know the radian? You know the difference between radian and degrees. Okay? So this is called the cosine of pi over 2. Cosine pi over 2 is equal to 0 and cosine pi over 2 is equal to 1. Cosine pi over 2 is equal to 0, sine pi over 2 is equal to 1. Okay? So let's check this, pi over 2 and pi over 2. So that will be 0 and that will be 1, like this. Now when you go to this point, this is the cosine of
That's
pi. Yes, that will be pi. This angle is called pi. This angle is called pi. And this will be sine pi. So we have sine pi is equal to 0 and cosine pi is equal to -1. And so on. This is cosine 3 pi over 2, or when we say it as minus pi, and that will be minus pi over 2, and this will be sine 3 pi over 2. So that will be -1 like this, and so on. Then I repeat my cycle again. I'll just start at the same point from which I start. Okay, so I'll start again here from the first point. It'll be like this, and that will be like this. So the graph will be something like this. The graph will be something like this. And if you just continue on your path, you will just repeat the whole thing all again. Okay, so that will be repeated again. And so for the cosine, it will be like this, and so on. Okay, so this is the cosine and this is the sine. We need to know the domain and the range of the cosine and sine. What is the range of the sine and cosine? The range. It is the range or the output or the y, or the output of the sine or cosine is always inside the interval from -1 to 1. Yes. So the range is equal to -1 to 1. What about the domain? Yes, the domain is R. Domain is just R. So the sine and cosine just take anything inside. Anything inside, there is no restriction. There are no restrictions to what you put inside a sine or a cosine. You can put anything inside it and there will be a sine or a cosine for it. So, and this is also for the range and the domain of the functions sine and cosine. Okay. So we have known the graph of the trigonometric functions. There are some rules that you need to know or you need to revise. You need to revise rules such as cosine squared plus sine squared is equal to, do you know what is cosine squared plus sine squared? Yes, it's equal to 1. From where did I get this? You just get it from the circle also. This is the circle, this is the triangle. If you take the radius is equal to 1 and this is x and this is y, so that will be cosine squared and that will be sine squared, that will be equal to 1. Okay? Another rule which is 1 plus tan squared is equal to sec squared. This is a rule that you need to remember. 1 plus cotan squared is equal to cosec squared. What is cosec and sec? The reciprocals of the trigonometric. So we have these three. We have these three, and also we have the reciprocals. This is the reciprocal or 1 over sine, which is called cosec. cosec x, which is c over b. What is the reciprocal of the cosine? It is called sec. So that will be c over a. What is the reciprocal of the tan? It is called cotan. Yes, cotan, that will be a over b. So just remember, whenever I have a code, the reciprocal will not have the code, and vice versa. Okay, whenever you have a code, that will not have a code. Now that sign doesn't have a code. So whenever you get the reciprocal, it will have a code. And this tan doesn't have a code. When you get the reciprocal, it will have a code. Okay? So this is the rules of trigonometric functions. Also, you need to remember the rules of the double angle relations. Double angle relations are very important. So we have sine 2x. Do you remember the rule?
Sine
2 sine cosine. Also we have cosine 2x is equal to cosine squared minus sine squared. And we have other two rules, which are 2 cosine squared minus 1 or 1 minus 2 sine squared. So these are the rules of the double angle. Okay, and also we have another 3 rules which are very important to us. No, how to make it from second degree to first degree. What is meant by that? If I have cosine squared x or cosine squared angle, sine squared angle, and sine cosine angle. There are just re-expression from these 3. A re-expression from this, but it is in a form that is more applicable. In mathematics, we just need to make the sine and cosine to be power 1. Whenever I find cosine squared, sine squared, or sine times cosine, this is a second degree. These are second degree terms. We don't like second degree sines and cosine. Second degree. We don't like them. We just like them to be first degree. So we just make use of these rules to make new rules. Cosine squared, it is half 1 plus cosine half the angle. Double the angle. And that will be just a similar expression but the minus. Cosine double angle. And that will be half sine double angle. So these rules are very important to us. Cosine squared, sine squared. Why they are important? They can make or can change second degree cosine and sine to the first degree cosine and sine. Degree 1. All the sine and cosine on the left side, on the right side are power to 1. To power 1. Okay? So these are 4 trigonometric functions. The main rules for it. Okay. Also, we have to know the exponential function. What is the exponential function? Exponential function, it's called f of x is equal to a power x. A power x either have this graph or this graph. For a greater than 1 or a less than 1. If a is greater than 1, it is just like 2 power x. How do I graph 2 power x? It will just be something like this. When x is going to infinity, it will just be growing to infinity. When the x is going to negative infinity, it will be to 0. Do you know what is 2 power negative infinity? What is 2 power negative infinity? No. 2 power negative 1, this is just exactly 1 over 2 power infinity. What is 2 power infinity? If you have a great number, when I say a number that is a big number or a great number, it is just greater than 1. Any number greater than 1, I call it just a great number. A small number, it will be just less than 1. Okay? Now if I take that great number 2 and I multiply it by itself infinitely times 2 by 2 by 2 by 2 by 2 by 2, it will be a very large number. So that will be 1 over infinity. What is 1 over infinity? 1 over a very large number It will be a very small number, yes, that will be 0. So that's why when you go to negative infinity, it will just approach 0. It is just approaching to 0. Okay? Now if I have a function half power x, now it will just be the opposite. It will be something like this. And for the two cases, when I put x equal to 0, anything power 0 is equal to 1. So that will be 1 like this. That will be 1 like this. Okay? Now half power infinity and half power negative infinity. Half power infinity is equal to, if I multiply half by half by half by half, it will just be 0. Just lessens, more and more. Okay? So it will be 0. Half power infinity, because this number is less than 1. It will be 0. Half power negative infinity, that's exactly the reciprocal. It will be 2 power infinity. What is 2 power infinity? 2 by 2 by 2 by 2? No, this is exactly infinity. So that's why half power negative infinity is just going to infinity in that way, that side. And it is going to 0 for this side. Okay? Now this is for the exponential function. What are the domain and the range? The domain and the range. What are the domain of the function? Either this one or this one. They are the same. The domain and range. What is the domain? Yes, R. The domain is R. It accepts anything inside. It accepts. So there are no problem in accepting anything inside the exponential, or the power for the power of the exponential function. Okay, either this one or this one. Okay, so the domain is R. What about the range? What about the range? The output of the function. Is the output of the function any y, or it is just in the opposite side of the y? So what would be the range? It would be from 0 to infinity. Or it is R positive. R positive. That's why we say that any exponential function is opposite. The result is opposite. Any exponential function is opposite. And remember that we put this expression a is always negative, is always positive. We don't take the case where a is negative. For the case a is negative, it gives many complications. For example, negative 1 power half, and this is a complicated case, or out of our scope. But we just consider the case where we have a is positive. A is positive. Whenever it is greater than 1 or less than 1. It may be greater than 1 or it may be less than 1. Okay, so this is the case in this case, and this is the case. You need to know the two cases. You need to know the two cases and how to graph the two cases, and also you need to know the domain and the range. The output of exponential is always positive. Okay, the output of exponential is always positive. Okay. Also we have yes, the natural number e. The natural number e. The natural number e. The natural number e, it is a number that we have found to be very special. It is a universal number, just like the pi. Just like the pi, it is a universal number. That e, it is 2.71 and so on. And we built the most basic function, which is called e power x. So this is the master of the exponential function. The master of it is called e power x. Why? We will know that this function is the only function that has its derivative in the same as it is. It is the only function. What is the derivative? We'll just know by 10 minutes from now. So y is equal to e power x. Now this e is 2 plus, what would be the graph of this function? Would it be like this or would it be like this? Can you remember? Just graphed. I'll just give you a hint. So look at this again. What would be the graph of e power x? Would be the left one or the right one?
The left one.
Yes, the left one, because e greater than 1. E is greater than 1. So the graph would be something like this. So this is the most important exponential function. The most important exponential function, and the most simple also. We will know why by the way. Okay. Okay. Also, we have the logarithmic function. Have you studied the logarithmic function before? The log. Yes, the logarithmic function. Logarithmic function. A logarithmic function is just, it is called the inverse of the exponential. What is meant by an inverse of a function? Do you know the root and squaring are functions that are opposite each other, or that are inverse to each other. The root and squaring, they cancel each other. So that's why for the logarithmic function also cancel the exponential function. Logarithmic and exponential are inverse to each other. Okay? So when I say log 100, what is log 100? When I say log, I must state what is the base. What is the base? I, for example, say 10. Log base 10 of 100. What is log base 10 for 100? Now remember, yes, it's exactly 2. Why? The log is always an exponent. The log, remember, that the log is always an exponent. Okay? So when I tell you what is log 100, you just ask what is the base. So are you thinking about the base of 10? So what is the log? The log is the exponent of the 10, which will be 2, just to get that number. 10 power what to be 100. So that is what is just the log. That what is just the log. Okay? So the log is always an exponent. The log is always an exponent. Okay? So if I say log base 10 for 0.001.
Minus 3.
Yes. I just write this as 10 power negative 3, and this is the exponent, so that will be, so the log is the exponent. The log is the exponent. Now, as well, the most important base for the exponential function was the e, the natural number e. And so will be the most important logarithmic function will be called the natural logarithm, which is symbolized by ln, denoted by ln, logarithm natural, ln. So what is ln? When I say ln e power 3, ln is just the log of base e, So when I tell you ln e power 3, you are just asking what is the exponent of the e that gives me that number. What is the exponent of the e in this case? It will be just 3. And this is general rule. Whenever I have ln e power something, it will just be, that will cancel, the ln and e cancel each other. The ln and e will cancel each other. So that will be that something as it is. And also for the opposite case. So when I say e power ln something, the e and ln, they cancel each other. So that will be that something. But there is a condition in this case. I don't have, if I have any number in between them, that's why I will just not apply the rule. Okay? For example, if I have e power 3 ln x, yes. I learned before the rules of the ln. What is 3 ln x? There is a rule which is called 3, yes, it can be, go up to the exponent. So that will be ln x power 3. You need to revise the rules of the logarithmic function. The rules of logarithmic function will be like this. So I may not cancel these like this. This is wrong. How would I deal with this function? No, I need for the e to cancel the ln. For the e to cancel the ln, they need to be a direct operation. Okay, or a direct effect. But there is a 3 which is in between them. No, I need to How to get rid of this 3?
Multiply.
Yes, by the rule, just by the rule that I've said. That would be e power ln x power 3. Now it is ready to be cancelled. So that will be e power ln, that will be x power 3. So the result of this will be x power 3, not 3x. Okay. That for the e. What is the graph of the ln? Logarithmic function. Logarithmic function. Yeah, the graph would be something like this. Whenever I have a function and its inverse, okay, there is a reflection about the y equals x. For example, the root x and x squared. These are inverse functions. Okay, this function is x squared. I will just take the positive side. I will just tell you now why. I'll just take the positive side of the x squared. If I need to find the graph of root x, how would I find it? I just make a reflection about the y equals x. If you make this reflection, it will be something like this. And this is exactly the graph of root x. So how would we get the graph of root x? I get it from a reflection by the line y equals x. Why? Because these are inverse to each other. Now we have learned that e power x and ln x are inverse functions to each other. E power x and ln x are inverse functions to each other. So this is the graph of e power x. What would be the graph of ln x? I will just make a reflection about y equals x. So let's see the new graph. The new graph would be something like this. This is 1, this will be also 1. This is 1 because e power 0 is equal to 1. E power 0 is equal to 1. So that blue graph is just the ln. Now look at this. This is the graph. Now I want you from this to tell me what is ln 1 and what is ln 0 and what is ln infinity.
Ln 1 0.
Yes, ln 1 is equal to 0. Correct. What is ln 0?
1.
Yes. No, not correct. Just look at the graph. When you go x, let x go to the 0.
No.
What would the graph go to?
5. Yes.
It would go to negative infinity. It will go to negative infinity. So ln 0 is equal to negative, or we say it go to negative infinity. So what is ln infinity? When you go into this side, yes, the graph will go to 1. It will go to positive infinity. It will go to positive infinity. So ln 1 is 0, ln 0 is negative infinity, ln infinity is infinity. Okay? Okay. Now, so this is a very very condensed form of the function or revision of functions. I will upload you some detailed explanations for, because it is all in the curriculum. So you may be asked any of the details of the functions. Okay, but there is no time to give it in lectures, because all of this is a revision for what you have taken before you have entered the university. So a detailed, if you need to revise what you will need, I will just upload you some. If you notice, I've just on the video is called long form. I will call it long form videos. They are long videos that you at home just open it and you watch these long videos if you need to revise more in more detail. Okay. Now we need to know the concept of differentiation, or the rate of change. Also, you must have been studied this before. What is a rate of change or what is differentiation? A rate of change is called dy by dx. A derivative which is called dy by dx if I have a graph of the function y is a function of x. y is a function of x. So what is dy by dx? It is how would I make, what happens if I make a little change in x. If I make a little change in x, I will call this little change, I will call it dx. What is that dx? Dx is not a number, it is just a number, it is called infinitesimal. Infinitesimal is just the opposite of infinity. Infinity is not a number, it is just something that is still grows forever. Grows forever. It is not a number, it is not stable. So I cannot consider it as a number. But I just symbolize it as like this infinity. What is infinitesimal? Infinitesimal is just 1 over the infinity. It is just a number that is not zero. It is not zero, exactly not zero, but it is number that approaches zero but never approaches. So it would be 0.000001 with infinitely many zeros here. So it is a number that just keeps not growing, it keeps dying. Okay, it keeps dying, but it never gets to zero. So that is called infinitesimal. So whenever I make an infinitesimal change in x, what happens to the y? It will have also an infinitesimal change in the y. There will be an infinitesimal change in the y. The ratio between these two is called the rate of change. The rate of change, or the differentiation, Okay? The definition of this one is called limit delta x go to 0, f of x plus delta x minus f of x over delta x. What is that called? Okay, this is x. I'll just put you, this is x, this is x plus delta x, and this is f of x, and this is f of x plus delta x. That is what symbolizes the dy, what happened in y, and this what happens in x. And happened in x is the dx, or I call it at first I call it delta x. When I say delta x go to 0, I call this dx. When delta x approaches 0, it is going to 0, I call this dx. Okay? So that will be dx, the denominator will be dx, and above will be the dy, or the difference in y, what happened in y. The difference of what happened to the y. Okay? Now, how would I calculate this? They have taken all the effort for us, and they made a table for differentiation. Table of differentiation. What is table of differentiation? There are some rules. Maybe you have learned it before. I think you have learned it before. If I have some function, for example, if I have x power n, do you remember how to make a differentiation of x power n? I just take the n down and make it xn minus 1. Yes, I take the n down and xn minus 1. Okay, and for the exponential, when I say e power x, its derivative is exactly, and that's why e power x is special. Its differentiation is the same. Okay. Also, we have when you say a power x, you can say it a power x. Its derivative will be the same, but you multiply by ln a. You multiply by ln the number that took the place of e. You multiply by ln the number that took the place of e. Okay. Now also we have the trigonometric functions. First, okay, let's take ln. What is the derivative of ln? It will be 1 over x. So this is memorized. The derivative of ln is 1 over x. Okay. Also we have the trigonometric functions. Sine x, cosine x, tan x, sec x, cotan x, and cosec x and cotan x. Cosec x and cotan x. Sine x, derivative of sine is is cosine. Derivative of sine is cosine is negative sine. Yes. So whenever I have a code, the derivative will be negative. Whenever I have a code, the derivative will be negative. Tan x is sec squared. Sec squared. Sec is sec tan. Now this is the derivative of the function, not the function. Some students put sine equal. No, it is the derivative of the function. Cosec is negative. So we have a co. So it would be negative cosec cotan. Cotan x will be negative cosec squared. Negative cosec squared. Okay? So this is the table of differentiation. But the table of differentiation is not enough. I need many functions to find its derivatives. How would I make the derivatives of many functions? Yes, I need the rules of differentiation. Rules of differentiation. What are the rules of differentiation? Rules of differentiation. First, if I have a function plus function, the derivative is just will be the derivative of this, then this. Very simple. It is called linearity. If I have a constant a f of x plus b g of x, the derivative will be a f dash of x plus b g dash of x. So, for example, if I have 7x power 7 plus 2 ln x, what is the derivative of this function?
7
f dash x will be 7 times 7 is 49 x power 6 plus the 2 as it is, and the ln, what is the derivative of ln? 1 over x. Derivative of ln is 1 over x. Okay, so this is the first rule. Whenever I have a constant, we take it, leave it as it is, and make the derivative of the n, put the plus as it is. Okay. Also we have multiplication rule. We have the multiplication rule. So if I have, for example, f of x is equal to x cubed sine x. Now we have two functions. We have the two functions in the table. We know the two functions are in the table, but they are now multiplied by each other. How do I find f dash of x? Now we have a rule. What is the rule? Yes, if I have fg, what is the derivative of fg? It is called the first derivative, the first, then derivative of the second, then I interchange the derivative for each one of them and keep the other as they are. Okay? So fg dash, I will take the first as it is, x cubed, then I make the derivative of the second, so that will be cosine x. Plus, I now interchange. I make the derivative of the first, so that will be 3x squared, and the other one will be as it is. Okay? If I have three functions, what would be the case? For example, f of x is equal to x cubed sine x ln x. If I have three functions like this, and I need to find f dash of x. So I make the derivative for one of them only. Then interchange the derivative between them. Let's check that. I make the derivative for the first, that 3x squared, and leave the others as they are. Plus leave the x cubed and leave the ln, but make the derivative of the second one, which is the sine, it will be cosine. Plus, now leave the x cubed as it is and the sine as it is, but make the derivative only for, so that will be 1 over x. So that's the derivative of three multiplied functions. Okay? So this is called the multiplication rule. Another rule is called the quotient rule. Quotient rule. What is the quotient rule? If I have, for example, x squared over ln x, and I need the derivative of this function. What is the rule? Now, pay attention. I make squaring of the denominator. So the denominator is squared, and by derivative, I make the derivative of the numerator above. Okay, I make the derivative of x squared to be 2x. Now I complete the numerator just as the rule of the multiplication rule, but with a negative sign. So I made here the derivative of x squared. I will take the second as it is, minus, not plus as the multiplication rule, minus the first as it is, x squared, by the derivative of the ln x, which will be like this. Okay, so this is how we apply a derivative of 1 over. What about this function 3 over x? 3 over x, and also the function 3 over x cubed. I need to find the derivative of this function.
minus 3.
Do I need here to apply the quotient rule? No. Yes. This is just exactly 3 power minus 1. So f dash will be, I will just take the negative down, so that will be negative 3. Negative 3x power negative 2. That will be negative 3 over x squared. And this is a rule that is, in general, is memorized. 1 over x, its derivative is minus 1 over x squared. Also, root x, its derivative is 1 over double root. 1 over double root. So what about this? This is 3x power minus 3. So its derivative will be, now I want you to pay attention that I am not putting equal. I'm putting an arrow. What does that arrow mean? I'm finding the derivative. So this is the derivative. Okay, that arrow means that will be negative 9 x power negative minus 4. Yes, so that will be minus 9 over x power 4. Okay, and the next time we will learn that there is still one rule which is called the chain rule. The chain rule. Whenever we put a function inside the function, we need to find how to find the derivative in this case.